Okay, hi. I must say I'm pretty excited to be on the stage today. The fact that we're all wearing headphones kind of makes it easier. So let's see how it goes. So nice to meet you. My name is Dalya Gartzman. I'm an algorithm researcher in VIA, and I want to talk to you today about offline solutions to online problems. So I'm going to start by talking about the online problem. So VIA is a ride-sharing service, which means that instead of ordering a car, you order a seat in a car. So imagine a very bright future in which VIA is operating in Tel Aviv, and I want to get from my Frischman apartment to my VIA office. So I open the app, I book a ride, and the app sends a car to come pick me up, where I actually booked a seat in that car. So now let's imagine that a neighbor also ordered a seat in a car, and they also want to get to a destination that is quite close to mine. So it would make sense that we both get seats in the same car. But since we have an online algorithm, the online algorithm already sent the car a few minutes ago, and so it's possible that we are already too far along on our trip to make the adjustment in the route to pick up the other person as well. And so the other, oh no. And so the other person cannot join my ride, and they will be very sad, and maybe me also. So what if we had an oracle that could tell me in advance of both rides? Then I could plan my route in advance, and we could all ride together and make the proper adjustments in the first place. So, the motivation of the project I'm going to talk to you today is that the online algorithm focuses on individual actions, and the purpose of this project was to take a step back, look at the big picture, and see what insights we can gain from looking at the data as a whole. And was it any good? Well, the short answer is yes, and I want to convince you today why offline solutions to online problems could be good for everyone. And I'm going to do it by reviewing three main insights that we gained from this project. So first, I want to set the stage. The experiment goes like this. Okay, let me go a step back. Since I don't have an oracle in real life and I don't know the future, what I can know is the past. So in this experiment, I took actual ride that took place in a city, in one morning in a city that VIA is operating in. So my input is requests, all the requests that the system saw that morning. And now I take this input and I put it into two different algorithms. One algorithm is a simulation of the online algorithm that we have in VIA. So think about it that even though I have all the data at hand, I stream it into the algorithm in an online manner. And the other algorithm is an offline algorithm that I wrote, which takes into account all of the data at the same time. And so I take these two algorithms, and I ran three simulations with three numbers of events. And the first thing I see is that gladly the offline algorithm has better performance, which means that with the same number of cars, the algorithm is able to pick up more people. So the first thing I look at this data, this was like the initial results that I saw, and I look at this and I see what insight can I learn from this. So let's look at the pie of all the people that booked a ride through the app. And let's look at the portion of the pie of the people that weren't able to get a ride. So my purpose as the algorithm designer is to decrease the portion of unmet demand. So how can I do that? Well, okay. So what if I could convince a portion of my users to pre-book their ride? In that case, I could kind of imitate the oracle that knows all the information in advance and use my offline algorithm to give better assignment for the people who pre-booked the ride, and then I could serve more people and give more rides to people. So just like looking at the initial results of this experiment, I can gain kind of a business intel out of the box. The second item I want to share with you, so this is again the same experiment, and we see here the lag between the time of the request and the time that the car in the simulation actually came to pick up the person. So this is basically like the time you wait until the car arrives. And we know that maybe around 8 a.m. is the rush hour. And I look at this graph, and I see in blue is the offline algorithm, and in orange is the online algorithm. And as of the rush hour, they pretty much interchange in the waiting time. So it sort of suggests that there's like a constant trade-off between how many people I'm able to pick up and how long does it take me to get there. But I also look at this graph just before 8 a.m., just before the rush hour, and I see that there's a significant difference, and the offline algorithm only picks up rides that are very close to, that has a very short waiting time. And I look at this, and so I will, okay, sorry, 1 second. Okay. So it looks like the algorithm is kind of preparing for the rush hour and kind of making a conscious decision on which rides to take and which rides not to take. So for example, let's look at this ride. So maybe just before the rush hour, if I was using the online algorithm might have looked at this ride in red and think that maybe it's very similar to all other rides. And maybe they would go, the online algorithm would have sent a car to pick up this person, and then maybe miss some rides at the center of the rush hour. But maybe the offline algorithm would have looked kind of like at the big picture and say, maybe it's not good for me to get away from the center of the rush hour, and I will not take this ride, and instead I will only take rides that are in the center of the rush hour. And this is already an insight that I can imitate in my online algorithm. So from looking closely, more closely at the data, I can gain insights on, like actionable insights of what I can learn from my offline algorithm and implement in my online algorithm. The third and last item is the detour data. So we said Via is a ride-sharing service, so I want to allow the cars to make detours in order to collect a number of people. And here again, I look at the data of that morning, and I see that around the rush hour, there is a strong correlation between the offline algorithm making shorter detours and the fact that I know that the offline algorithm picks up more people. So I see a correlation between shorter detours and picking up more people, but we all know that correlation is not causation, because if I prevent my algorithm from making detours, I'm preventing the algorithm from making the proper adjustment it needs in order to aggregate the rides. So it's not like I can look at this and I say, oh, now I can implement this in my algorithm. But what I can learn from this is that I have a place where I can drill further down and look more closely at the data. So I said the purpose of the offline algorithm is to look at the data as a whole and look at the big picture, but what it also gave me is an insight of where I can zoom back in and look at specific features of my algorithm in order to gain more insights. So to sum up, I showed three key insights that we had from the algorithm, which is business intel out of the box, actionable insights, and a place where we can zoom in and drill further down. And you may ask me, wait, but you could also like run the online algorithm with the same parameters that imitate these features and gain the same insights. And that's a good point, and thank you for raising that. But the fact is that there are countless such insights. And what I need as a person who is dealing with vast amounts of data, and I have vast amounts of insights to explore, is an automatic tool that lets me surface those insights so that later I can implement them in my online algorithm. So, in short, doing this project was took a lot of resources, but it was also a lot of fun, and it gained us a lot of insights that we could implement from our from our offline insight generator to our online algorithm. And I hope I convinced you that this is a good idea, and that you could also find a way to take your online algorithms and find an offline simulation that can generate insights for you to implement in your online algorithm. So anyway, that's it, and thank you for listening.